Hi everyone, I'm volcanologist Dr. Janine Kripner, and this is my guest.
Hi, I'm Glyn Williams-Jones, and I'm a professor of volcanology in the Department of Earth Sciences at Simon Fraser University in British Columbia, Canada.
Thank you. I'm very happy to have someone on here talking about Canadian volcanoes, because a lot of people don't know that Canada has volcanoes. How many volcanoes do you have there?
So that's a big question. How do we decide which is a volcano and which isn't, and is it active
Policy?
or not? So we've probably got, at the moment, we have one active volcano that we know of, because we can see gas coming out of it, and there's been some earthquake activity, though very minor.
Okay, well there we go. Canada, you have volcanoes too. So Glyn's going to chat to us about a block and ash flow deposit that really got my interest up. So a block and ash flow deposit is a deposit that forms during a type of pyroclastic flow called a block and ash flow. And this is specifically when a lava dome, so a plug of lava that's moving up at the surface, collapses. So can you please tell us about this fantastic sample that you have?
So yeah, we're going to sort of tell the story of this block and ash flow sample. And as Janine said, typically we're looking at a dome that's failing and it's breaking up. And you can see this shiny black, almost obsidian-like piece. That's a fragment, a block. And then the gray material is the ash. It's all the same material, but the ash is just pulverized components of this dark black material. What's really odd about this is that it's glued together. This piece has welded or melted itself back together. And it's quite a neat story about how that actually happened.
Yeah, absolutely. I'd never heard of a welded block and ash flow deposit before. You mentioned this on Twitter several days ago. So how did this actually happen?
So this eruption, it's a volcano about 150, 60 kilometers north of Vancouver called Mount Meager. And about a little over 2,400 years ago, as you said, this big plug of lava came up and onto the side of the volcano, starting to ooze out, and then it failed. It just couldn't, it was too sticky. It broke up into pieces, turned into this glowing superheated cloud of ash and blocks, and flowed down into the nearby river valley, the Lillooet River. And because of that valley, the material couldn't go anywhere, so it bulked up. It filled up that entire river valley and formed a dam about 3 kilometers long and 110 meters high or thick. Completely melted itself back together again, and so became an impermeable barrier to the river. It then built up a large reservoir. That Lillooet River formed a huge lake behind it. We think, thanks to the work by my good friend Kelly Russell at UBC and his team, that it formed a lake maybe half a cubic kilometer over a couple of months. And then the volcano was probably still erupting, depositing loose, unconsolidated or unwelded volcanic ash on top of that dam. The reservoir filled up, started to percolate into that loose material, and then failed catastrophically in an outburst flood.
This is, I tell you, if there are going to be things keeping me up at night, volcanoes forming their own lakes and then those lakes catastrophically draining is just a kind of a nightmare scenario. So thank you very much for that. I'm glad people are working to understand how these things work so that we can eventually keep people hopefully safe, or at least evacuated out of the way. So thank you so much for joining me for this volcano moment.
My pleasure, and thanks for doing this. This is great.
Thank you so much.